Hello, everyone, and welcome back to another episode with your girl, Audrey Codner-Gibson from ACG Math Tutoring. Yes, I was going to do this. All right, so we are continuing on to get on those algebraic foundational skills so we can get ourselves situated for our next step in life. Yes, in life. All right, so hopefully you guys are getting yourself ready because I am ready to teach. All right, everyone, so we are adding and subtracting algebraic fractions with the binomial, yes, denominator. So we are going to be doing a little bit more factoring, just try to break everything down. So in order for us to do this, we're going to look at those Common Core standards, our A-APR 0.7 and A-REI 0.2. So before we get started, we're going to look at our review from the last exit ticket. So we were basically adding, subtracting those algebraic fractions when we had unlike denominators. So if you need to review that for me, go ahead and look in there and just go ahead and hit play, and then you can jump right in from this point on. So what we're going to do right now, we're going to simplify 3x over 10 plus 7x over 5. So if you recall, anytime you have a fraction, if you're adding or subtracting, you always have to have a common denominator. So we have 10 and we have 5. So with the 10 and 5, I got to think of those multiples. So if I got my 10 times table, so we got 10, we got 20, we got 30. And my 5 times tables, we got 5, 10, 15. So what numbers do you notice that they have in common, which is my least common multiple, is going to be 10. So that means this first fraction is just going to stay right where it is. But that second fraction, we're going to have to do some multiplication. So in order for me to change this 5 to a 10, I need to multiply it by 2. And whatever I do in my denominator, I have to do in my numerator. So that means my numerator is now going to be 14x. So I'm going to bring down my plus sign, bring down my 3x and the 10. So now I have the common denominator, so I can just go ahead and add the numerators. So 3x plus 14x, that gives me 17x. And it's not 17x squared. You only get that square when you multiply. So we're just adding. And then we're going to keep our denominator, which is 10. So now I'm looking, 17 and 10, do they have anything in common other than 1? No. So that means I can't break this down any further. So this 17/10 x, that is my answer. So what we're going to do today, kind of switch up the learning target and agenda a little bit. You can say to yourself by the end of this lesson that I can add and subtract algebraic fractions with the binomial denominators. Okay, so we are going to be looking at some guided notes and some examples. We are going to do a little practice problem, and then we're going to finish up with our traditional exit ticket. So, couple helpful hints. First thing is similar to what we've been doing with the other fractions. We need to find the lowest common denominator. So we need to have a common denominator, and we want to look for the lowest one. So like our review that we had just a couple seconds ago, we could multiply the 5 and the 10 together to get 50, and then you have to multiply both of the fractions. But sometimes it's so much easier to find what do they have in common in its lowest form. Then we want to update our denominator, just like how we did in the review. We're going to complete whatever the appropriate operation is, if it's addition or subtraction, and then reduce if needed. So here's the key thing, please watch your signs, okay? So let's get with examples, because I'm a visual person. I like to see it instead of me just yammering on. So we have 6 over x plus 3 plus 3 over x minus 1. So if I look, I have x plus 3 and x minus 1 as my denominators. So right now, it's not like you can do what we did earlier. Like say, okay, let me take the multiples of 5. Let me take the multiples of 10. Right now, we have a whole expression. So it's kind of hard for us to be like, oh, okay, let me do all those multiplication tables. This is the easiest part for me. So I can actually say my LCD, my least common denominator, is going to be the combination of both expressions. So just like we did when we changed a 5 to a 10, we multiplied, we're doing the same exact thing here, but we're just going to multiply both expressions. So we don't have to do the distributive property. But in order for me to have this denominator, which is x plus 3 times x minus 1, and the same thing over here, I need to multiply this side by x minus 1. Whatever I do in the denominator, I have to do in the numerator. In order for me to get that same denominator, I need to multiply this side by x plus 3. Whatever I do in the denominator, I have to do in the numerator. So it's almost like there's like a crossing. So the x plus 3, it crossed over to the other side. The x minus 1, it crossed over to the other side, and then we multiply. So now I could just focus solely on the numerators. So for this first fraction, we have 6 times x plus 1. So it's like the distributive property. So that means we have 6x minus 6. That's going to be my new numerator. Now for the other ratio, or fraction, we're going to distribute the 3 to everything inside of its parenthesis. So 3 times x gives me 3x, and 3 times 3 gives me a positive 9. So now we have the same denominator. So we're going to focus solely on the numerator. So we're going to combine like terms. So I got my x plus 3 and my x minus 1. So now let's combine like terms. So we have 6x plus 3x. That gives me 9x. And then we have a negative 6 plus 9. Different signs, so that means we are subtracting. And we're taking the sign of our largest value, which is 9. So it's going to be a positive 3. Ooh, what happened? Okay, now, when I look at this, especially that 9x plus 3, I see a 9 and I see a 3. So that's telling me, hey, there's something in common. There's 3 in common. So I can simplify this even further. So when I look, I got my 3. That's my greatest common factor. So that means inside the parenthesis, we have 3x plus 1. Okay. So now I'm looking, can I simplify? Can I cancel anything out? If the answer is yes, go ahead and simplify it. But in this case, my answer is going to be no, nay, 9. Heck no. Okay. So we can't break it down any further. So this is my complete factorization of those two ratios when I do addition. Okay, I know it seems a little crazy, but let me show you with another example. Okay, so now we got 7 over x minus 1 plus 7 over 2x plus 3. So if I look at my denominators, they're not the same, so I can't just go ahead and add 7 and 7. Can't do it, all right, because my denominators are not the same. But I can say my least common denominator is me putting these two binomials together through multiplication. So one parenthesis is going to be x minus 1, and the other parenthesis is going to be 2x plus 3. Okay? So now, in order for me to have those common denominators for both of them, I have to do multiplication. So that means my first ratio on the left-hand side, I need to multiply it by that 2x plus 3. You see how it crossed over? Okay, so that means for the other ratio, I need to multiply by x minus 1. So now, do the distributive property. So 7 times 2x, that gives me 14x, plus 7 times 3 gives me 21. Now for the other ratio, we got 7x minus 7. So since my denominator is exactly the same, I'm just going to bring it on over. And now I'm going to combine my like terms of the numerator. So I have my x's first, so I got 14x plus 7x. That gives me 21x. And then I have 21 plus a negative 7. So that gives me a positive 14. Remember, unlike signs, you subtract and you take the sign of the largest value, which is 21. So now, after looking at this, I'm going to see if I can break it down some more. So I can factor that numerator a little bit, because 21 and 14, they both have 7 in common. So now inside this parenthesis, I got 3x plus 2, because I divide the 7, my GCF, by what was my original expression. So that's where that 3x plus 2 came from. Let me clean that up a little bit. And then I rewrite my x minus 1 and 2x plus 3. So do I have anything in common? No. No, you don't. You're saying, well, there's 3x and 2x and there's 2x and 3x. They're not the same. They have to be exactly the same. So if it's 3x on the numerator, that means it's 3x in the denominator. If there's a 2 as a constant in your numerator, that means there's a 2 and a constant in the denominator. So this is the complete simplification. Okay? Let's try another one. So, of course, I got to challenge it a little bit. So we have 6 over x squared minus 16 minus 5 over x plus 4. So they're not the same. Yes, I got to do multiplication, but wait. Every time I see a square, I should be thinking of my perfect squares. Okay, my 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. And the product that I'm getting after that multiplication. That 16, that is a perfect square root. That means if I break it down, I can split into my 2 parentheses, split my x's. I got 4 times 4, because 4 times 4 gives me 16. But we're looking for a negative 16. Remember the perfect, or the difference of squares? That's what this is. You see how everything carries over. You never just study it one and done. It always just carries over. So that means I have a plus 4 and a minus 4. So that's representing this. So this is no longer there. So now take a look at the denominator. There's an x plus 4 there. There's an x plus 4 there. That means this side, the right side, is missing an x minus 4. So we can get that LCD of x plus 4 and x minus 4. Okay? So just by breaking down that x squared minus 16 into its own elements, then you can see what's missing. So I didn't have to multiply the x squared minus 16 to, all I had to multiply is just one side. So this will stay exactly the same. I keep hitting things. My pen is keep rotating in my fingers, so I keep accidentally hitting the eraser or the next button. It's all kinds of fun in my world, all right? But now, knowing that my denominator is going to be x plus 4 and x minus 4, I need to multiply my numerator, that 5, to that x minus 4, which gives me 5x minus 20. So now, we're subtracting. We can do either keep, change, switch, or you can keep along, because remember, you are subtracting. So it's 6 minus 5x, which we can't do anyway. but then it's 6 minus a negative 20. So when you minus a negative, it turns positive. So in actuality, your numerator is negative 5x plus 26. And it's over x plus 4, x minus 4. Okay? Because if I keep, I change minus to a plus, and then I flip all my signs. So we got that one and we got that one. So that's why the 5x is now a negative 5x. And when we have 6 plus 20, that's where the 26 came from. All right? So now, if I can, 5 and 26, do they have anything in common other than 1? No, they don't. So this is my answer. I know it looks funky, but I can't break it down anymore. I can't cancel anything out. So that's it. That's what it is, okay? All right, so let's practice. So if you need to pause, go ahead and pause and then try to practice up, or you like, heck no, woman, I'm sticking right there with you. I'm perfectly fine with that. All right, so we're just gonna take it one step at a time. 1, look at your denominators. Are they the same? No, they're not. You have an x squared minus 9, and you have an x plus 3. Anytime I see an x squared, I'm going to see if I have a perfect square root, which I do. I have x plus 3, and I have x minus 3. Because 3 times 3 gives me 9, but since that 9 is negative, this is the difference of squares, okay? So the other ratio has x plus 3. So that means what's missing from them is that x minus 3. So this first one, we don't have to do anything. But the second one, we need to incorporate that x minus 3 through multiplication. So now, if I write it out, we have our x plus 3, x minus 3, minus, my denominator stays the same, which will be x plus 3, x minus 3. And if I multiply 1 to anything, it's always going to be itself. So now we just have to focus on the numerators. But please, please be careful with your signs. So we have x minus x. What's going to happen? They're going to cancel each other out. If you want to do keep, change, flip, you can do that. We're going to keep this x, we're going to change this to a plus, and we're going to flip all the signs over here. So you got x plus negative x, that gives me 0. They cancel out. I don't have to put that placeholder of 0 because it's already understood. That is gone. We don't need it. So now what's left is a positive 3. So do they have anything in common that they can cancel out? No. You're like, what? But they got 3s. Pardon me. X plus 3, that's representing one number. You can't split them up. You can't split the x, can't split the 3 up, okay? That x minus 3, same exact thing. You can't split them up, okay? If it was a 3 on the numerator, 3 in the denominator, 3 in the denominator, yes. But because those expressions do not equate to what's happening in the numerator, this is my final answer. Can't do anything else, okay? So it probably was a little bit rough, but through practice, I think you guys will be able to handle this. So I really believe that you can add and subtract algebraic fractions with the binomial denominator. I will admit it is a bit challenging, but once you understand factoring and be able to identify the difference of squares, and be able to understand that, hey, I'm looking at the LCD of the denominator, I think you're going to be all right. That's only 3 things, okay? So we did review the exit ticket. We looked at some guided notes and examples. We definitely looked at our practice problem. Now we're going to look at your exit ticket. So one problem and one problem only. So you are simplifying these problems, just like how we did with the lesson today. So you have 9 over x plus 1 minus 3 over 4x plus 4. So I just want you to try it out. And if anything, make sure you come back. I hope this didn't scare you off. And if you do need to review the other stuff, like how to do the difference of squares, remember, I did those videos. So if you look at Miss Codner-Gibson's Front Porch Tutoring playlist, everything is in there. I have a good 60 videos on there. So I went everything from like, what is a number to where we're at right now. So if anything, just go ahead and review back to those numbers. That's perfectly fine, or videos, that's perfectly fine. And if you do need any assistance and you do want to like, hey, Ms. Codner-Gibson, can you break this part down for me? Go ahead and put it in the comments and then we'll see what we can do from there on in. So if you do like these videos, I know today was a tough one. You're like, yeah, it was all right, because the content was a little bit harder. But if you do like these videos, go ahead and subscribe. Go ahead and hit the notification button, and please do not forget to share. So hopefully you guys are doing all right. Stick with me. Things are going to get a little bit tougher, but I'm here to break it down for you. All right? So hopefully everyone's doing all right. I'll talk to you later.